Okay guys, now if you remember, we have learned about in the ninth grade we have learned about the trigonometric functions. Yeah, you know that trigonometric functions are the trigonometry. Yeah, trigonometry is all about the ratios of the right triangle, the sides of the right triangle. Yeah. Now, if you remember, we have learned about what trigonometric formulas, that sum and difference formulas, reduction formulas, double angle and half angle formulas, sum to product and product to sum formulas. And also we have learned about trigonometry on the right triangle and trigonometric ratios on the unit circle. Just now let's let's now review about the unit circle. Why? Because that are very we have to know that to understand the next topic. Okay, trigonometric ratios on the unit circle. If you remember, now we said that we can find the values for the sine, cosine, tangent, and cotangent functions with the help of what? With the help of right triangle. That sine is the ratio of the opposite side to the angle and to the hypotenuse of the triangle. But what about the angles which are bigger than 90 degrees? So to find the values for trigonometric ratios for the angles bigger than 90 degrees, we will use, if you remember, unit circle. Yeah. Okay, unit circle in here, as you see, on the unit circle. If you remember, we have learned about now unit circle is a circle with the radius 1. If you and with the radius 1, and you know that sine is just the ratio of the opposite side to this angle, the opposite side of this angle over the hypotenuse of that triangle. Yeah, as the hypotenuse is equal to 1, and the value of the sine just is the length of this line segment. Yeah, if you remember, now as we increase the angle, now if we as we increase the angle, the length of this line segment is increasing. Yeah. Now, and when it's bigger than 90, the length is also. Now, after the 90 degree, the length of this this line segment is decreasing, and it continues to decrease at 180 degree. When this angle is 180 degree, it's in radians. It's pi. The value of the sine, the length of this line segment is very small, and the length is equal to 0, and that means the value of the sine is 0, as you see here. Okay, now if we start to continue increasing the angle, now the line segment is just increasing the length of the line segment, but in the opposite direction. Yeah, that so the value of the sine is negative. At 270 degree, it's in radians is 3 pi over 2. The length is equal to the length of the line segment is 1, but in opposite direction, so the value of the sine is -1. Okay, guys. Now on the unit circle, and also let's review about cosine. Okay, cosine here. To find the value of the cosine, we will look at the line, the length of this line segment. Yeah, why? Because on the right side in here, as you see, for this angle, the value of the cosine is adjacent side of this angle over the hypotenuse. Yeah, and as hypotenuse is equal to 1, the value of the cosine is the length of this adjacent side of this triangle. Yeah, as you see, as we increase the angle, the length of this line segment, adjacent side of this angle, is decreasing. At 90 degree, when the angle is equal to 90 degree, the value of the cosine is 0, because the line segment is 0. Yeah, as we continue to increase the angle. The line segment it's increasing but in opposite direction, so the value of the cosine is negative. At 180 degree, the cosine is equal to what? -1. And on 270 degree, cosine is equal to 0. At 360 degree, the value of the cosine is equal to 1. Okay, now shortly we have reviewed about unit circle. Now in the next video we are going to talk about the graphs of sine and cosine and tangent and cotangent functions. Yeah, we will look at the trigonometric ratios as a function, as a type of function. As you know, each function has its graphs. In the next video we are going to learn about the graphs of trigonometric functions. Okay.